Hello students, welcome you for this session regarding line coding. Line code is nothing but bit stream is going to have voltage levels, which is also considered as a waveform. So electric waveform, the signals are going to convert them into a electrical form. Why it is needed? So as we know that digital modulation techniques are very immune to noise. The noise is getting affected by this. Digital modulation signal is very less. So for that reason we go for digital modulation, but the disadvantage of digital modulation technique is it cannot cover a range. Okay, so for that reason it can be converted after modulating, can be converted to analog. So that is what the bit streams are going to be converted to a electrical form. And even though we represent in the bit stream, but finally when it is come to a semiconductor device, it is going to understand the language not in form of ones and zeros, it is in form of voltage levels. So for that reason we need to convert a digital signal into a analog signal. That particular signal is known as the PAM, that is nothing but pulse amplitude modulation techniques. So under this you are going to learn it as a unipolar return to zero and non-return to zero line coding technique, bipolar return to zero, non-return to zero line coding, polar return to zero, non-return to zero, and Manchester return to zero and non-return to zero line coding technique you are going to learn. So under this first one, it is a unipolar format, that is on or off signaling. How? For the duration, you can observe here, for the duration S, for the duration S1 of t, that is having the amplitude plus A. What is the duration? Duration is 0 to TB for symbol 1. Next, S2 of t is equal to 0 for 0 to T to TB for symbol 0. Now it is going to have two durations. So one is the plus A, which represent the bit 1 for the duration TB. 0, which is represented by the bit 0 having the duration TB. So both are having the TB duration. So 0 is represented by bit 0, plus A is represented by bit 1 having TB duration 0 to TB. So now what is the difference between the return to 0 and non-return to 0? The bit 1 is going to cover entire the duration 0 to TB, which is considered as non-return to 0 coding technique. So which is considered as non-return to 0 coding technique. So if it is half of the duration, say TB by 2, okay, so rest of the duration it is 0, then it is considered as the return to 0 unipolar format. The naming is only suggesting uni, only one side, it is going to be a signaling, that is only signal 1, which is bit 1 is having the amplitude levels, whereas bit 0 is having the DC level. So this is the disadvantage in case of unipolar non-return is 0. At the receiver, if it is going to receive a consecutive zeros, then it is very difficult to decode at the receiver side. So unipolar return to 0 signaling, return to 0 means, as I mentioned, half of the duration it is going to existence of the bulb, rest of the duration it is going to have DC level, that is 0. That is S1 of t. S1 of t is equal to plus A for the duration 0 to TB by 2 for symbol 1 and is equal to 0 for TB by 2 TB. Similarly, S2 of 0 is 0 for all the duration, so it is considered as 0. So this is about unipolar format. So when you come to the polar format, so in the polar format, positive pulse is transmitted over the symbol, positive pulse is transmitted over the symbol 1, negative pulse is transmitted for symbol 0. Symbol 0 is considered as negative amplitude and symbol 1 is considered as a positive amplitude. So this is the waveform technique for the polar non-return to 0 technique. That is, symbol 1 is going to have the positive amplitude, symbol 0 is going to have negative amplitude. Again it is positive, and here two zeros, two negative amplitudes, two negative amplitudes, and here it is again plus, and here it is minus, plus and minus. So when the pulse occupies the full duration of the symbol, the unipolar format is said to be a polar non-return to 0 type. Full duration for for bit 1 as well as bit 0. So when it is going to the signals which are going to transmit half of the duration, then it is going to be return to 0 type. So when the pulse occupies one half of the symbol duration, and it is said to be a polar return to 0 format. So that is what the plus A for the duration 0 to t to t by 2 for the symbol 1, and 0 for rest of the duration, that is tb by 2 to t to tb. Okay, so now S2 of t is equal to minus A for the duration 0 to t to tb by 2 for symbol 0, and 0 for tb by 2 to tb. So this is about polar signaling. So which is going to give positive amplitude, positive pulse for the symbol 1, and a negative pulse for the symbol 0. So the next line code technique, very useful line coding technique, is bipolar format. So here it is going to have three voltage levels. So that is plus A, plus, minus, and 0. Okay. So what is plus is indicating this is also bit 1, this is also bit 1. But plus amplitude or plus pulse is for odd number of ones. So plus pulse is for odd number of ones. So you can it is odd number of ones, and minus 1 is for even number of 1. Minus 1 is for even number of 1. Even number of 1. Okay. So 0 is for bit 0. So this is going to be represented for bit 0. So now what is the voltage? That's why since it is going to have the three voltage levels, so this is known as the ternary coding, or else the since the amplitude levels are getting changed here, this can also be called as alternative marking inversion, that is what AMI. So this signal is also known as AMI, that is nothing but the alternative marking inversion, since it plus 1 for odd number of ones, minus 1 for even number of ones. So it is getting altered. It is also known as the alternative marking inversion. That is plus 1 for odd number of ones, minus 1 for even number of ones. So when it is going to transmit off of the duration, then it is going to be a bipolar return to 0 signaling. So when the pulse occupies one half of the symbol duration, it is said to be a bipolar non-return to 0 type. So that is what in the duration plus or minus A is equal to for the duration 0 to t to tb by 2, and is equal to 0 for tb by 2 to t to tb. So S of t is equal to 0 for the duration st to tb. So the next signaling is the Manchester format. So earlier what bit 0 is the DC level in the bipolar and the unipolar. So this can be avoided to represent a DC level for bit 1. That is nothing but here the bit 1 is represented with the pulse positive to negative. Bit 0 is represented with the pulse negative to positive. Negative to positive. So this is what the Manchester coding. Symbol 1 is represented by transmitting a positive pulse for real one half of the symbol duration, followed by a negative pulse for the remaining half of the symbol duration. Symbol 0 is represented by transmitting a negative pulse for one half of the symbol duration, and followed by a positive pulse for the remaining half of the duration. So this is what the Manchester 1 and 0. Here return to 0, non-return to 0 concept is not there, because the entire duration 0 to tb is covered by the amplitudes, okay, or pulses. Plus A represent the amplitude level from 0 to t to tb by 2 for symbol 1, and minus A for tb by 2 to t to tb, and minus A for t to 0 to t to tb by 2 for symbol 0, plus A for tb by 2 to t to tb. So this is about the Manchester line coding technique. This is also known as the biphase band signaling. This is also. So this is one more example to write the binary sequence for 10, 100, 11, 111, 00. Draw the digital format waveform for corresponding to unipolar non-return to 0, polar non-return to 0, bipolar non-return to 0, Manchester encoding, polar return to 0, bipolar return to 0 and unipolar return to 0. So first line coded technique, which is of unipolar non-return to 0, 1 0 1 0 triple 1 double 0. So polar non-return to 0 is again it is 1 for positive, 1 amplitude for bit 1, negative, positive, negative, again 3 positive amplitude levels, again negative amplitude levels, here it is negative amplitude levels. So when you transmit that into a half of the duration, it becomes a polar return to 0. So next is the bipolar non-return to 0 coding. So odd number of ones positive amplitude, even number of one negative, 0 is represented with DC level. So 0 is represent DC level, plus, minus, plus, and with respect to the DC level. So next Manchester coding. Next is the Manchester coding, that is positive amplitude is represented with the plus A to minus A, and 0 is represented with the minus A to plus A, and 1 is represented with the plus A to minus A, again 0 is minus A to plus A, again 1 is plus A to minus A, again 1 is plus A to minus A, plus A to minus A, minus A to plus A, minus A to plus A. This is the line coding for in case of Manchester encoding. And bipolar return to 0, if you consider half of the duration of the bipolar non-return to 0, that becomes bipolar return to 0, that is half of the duration of the pulse you need to consider. Even for the unipolar you need to consider half of the durations.